welcome to my video. In this video, we're going to learn about sequence and series. But before that, let me introduce myself. My name is Nimade Manika Prashanti with student ID 24130111063 and I'm from 4A class. Moving forward, let's get started with the core presentation on sequence and series. Have you ever wondered why we need to study sequence and series in math? What are the benefits? Questions like that will definitely arise whenever we have difficulty with a lesson topic, especially mathematics, right? Now, you'll know how important it is to understand this topic. The benefits are numerous, especially for your future career. Okay, let's first talk about sequence. In general, a sequence is a list of numbers that are ordered from left to right. Each sequence of numbers also has certain characteristic or pattern. For example, 3, 6, 9, 12, 15, and so on. Each number is called a term or UN. So, U1 or we can call A is 3, U2 is 6, U3 is 9, and so on. Meanwhile, a series is the sum of the term of a sequence. For example, if there is a sequence 3, 6, 9, 12, so the series is 3 plus 6 plus 9 plus 12 equals 30. There are two types of sequence and series. First, arithmetic is constant difference between terms. And second is geometric is constant ratio between terms. Next is arithmetic sequence and geometric sequence. An arithmetic sequence is a sequence of numbers that has the same difference between adjacent terms. We can call this difference a difference symbolized by B. An arithmetic sequence is the sum of the first n term in an arithmetic sequence. Okay, for example, we have a sequence 1, 4, 7, 10, 13, and so on. Here, the difference is plus 3 because we add 3 to each number to get the next one. Next, a geometric sequence is a pattern that has a constant multiplier or ratio for every two adjacent terms. The ratio in geometric sequence is usually symbolized by R. For example, we have 1, 3, 9, 27, 81, and so on. Here, the ratio is times 3. Okay, next, we talk about series. Arithmetic series is the sum of the term of an arithmetic sequence. For example, if you have a list of numbers where each number increases by 3, the series is the sum of those numbers which totals 35. And a geometric series is a pattern that has a constant multiplier or ratio for every two adjacent terms. For example, if you have a list of numbers where each number is multiplied by 3, the geometric series is the sum of those numbers, which totals 121. Now, we'll learn about the formulas for arithmetic and geometric sequence and series. You can pause this video to note down the formulas first. Okay, in arithmetic, we find the difference with formula b equals un minus 1. But in geometric, we find a ratio in formula un divided un minus 1. Okay, next we find the nth term. In arithmetic, the formula is un equals u1, or we can call a, plus 9 minus 1 times b. But in geometric, to find nth term, we use the formula un equals a times r to the power n minus 1. In arithmetic, we can find the middle term with formula ut equals half times a plus un. And we can determine which term is the middle term with formula t equals half times n plus 1. Okay? And then in arithmetic series, we can use the formula to find the sum of the first n term is Sn equals half times 2a plus n minus 1 times b. But in geometric series, first we look the ratio. If ratio more than 1, so we use the formula Sn equals a times r to the power n minus 1 divided r minus 1. But when r less than 1, we use the formula Sn equals a times 1 minus r to the power n divided 1 minus r. Okay? In geometric series, we can find infinite sum of terms. With use formula S infinite equals a divided 1 plus r. This is a description with b is the common difference between consecutive term, r is ratio, un is the nth term of the sequence, u1 or a is the first term of the sequence, un minus 1 is the nth minus 1 term of the sequence, ut is the middle term, un in middle term is the last term, n is the number or position of the term in the sequence, Sn is the sum of the first n terms, and the last S infinite is infinite sum of terms. Next, we learn how to use the formula above. The first question is, given the arithmetic sequence 5, 11, 17, 23 until 125, the questions are, first, find the 20th term of the sequence. Second question is, determine the index or position t of the middle term. Number 3 is calculate the value of the middle term or ut. Number 4 is find the sum of the first 15th term of the sequence. To answer this question, we know u1 or a in this sequence is 5. And difference on this sequence is 11 minus 5. We use different formula equals 6. Okay, next. To answer number 1 is find the 20th term of the sequence. We use the UN formula. This is UN formula. So we just substitute the value and evaluate, and we get U20 is 119. And next, question number 2 is determine the index or position T of the middle term. To determine the index or position of the middle term, first we find n with use UN formula, where UN is 125, and then substitute the another value, and we evaluate, and we get n is 21. And next, after we find n, we use the T formula. The T formula is half times n plus 1. And we substitute the value and evaluate, and we get T is 11. So, the position of the middle term is 11. And next, question number 3. Calculate the value of the middle term. For answer number 3, we just use UT formula, where UT formula is half times A plus UN. So we substitute the value and evaluate that, and we get UT is 65. And the last question is find the sum of the first 15 term of this sequence. For number 4, we just use Sn formula, where Sn formula is half times n times 2a plus n minus 1 times b. And substitute the value and evaluate, and we get S15 is 705. Okay, next question is, given the geometric sequence 3, 6, 12, 24, and so on, the first question is find the 8th term of the sequence. Second question is calculate the sum of the first 10 term of the question. In this sequence, we know U1 or A is 3, and the ratio is U2 divided U1. So we get the ratio is 2. To answer number 1, we use UN formula in geometric sequence, where the UN formula in geometric sequence is UN equals A times R to the power of n minus 1. So we substitute the value and evaluate, so we get U8 is 384. And to answer number 2, first we look the ratio. If ratio more or less 1. In this question, the ratio is more than 1. So we use the The SN formula is A times R to the power of n minus 1 divided R minus 1. And we substitute the value and evaluate, so we get S10 is 3069. And the last question is, calculate the sum to infinity of the following geometric series: 32 plus 8 plus 2 plus half plus so on. Okay, to answer this question, first we know A or U1 is 32 and the ratio is a quarter. So we use the S infinite formula and we substitute the value and evaluate, so we get S infinite is 42.67. Do you understand how to solve this question? If you don't understand, just ask. If you don't understand how to get the result, you can explain and complete it step by step. Okay? Okay, next is application, sequence, and series in everyday life. As explained earlier, learning about sequence and series has many practical benefits in everyday life. For instance, if you want to become an entrepreneur, the constant growth of your business over time follows an arithmetic sequence, allowing you to predict the scale of profit or loss you'll face. Beyond business, they can be used to calculate population growth, compute interest, annuities, and much more. Ultimately, all knowledge has its uses, so there's no excuse to be lazy about mastering this material. Okay, and that's a wrap. As we've seen, a sequence and series aren't just numbers on a page, they are powerful tools that help us navigate everything from business growth to financial planning. Remember, every bit of math you master opens up new ways to understand the world around you. So, keep practicing, stay curious, and don't be lazy about diving into this material. Thanks for watching, and I'll see you in the next lesson. Bye!